In this video, we're going to go over Heron's formula, as well as how we can find the area of a triangle using trigonometry. All right, so to begin, we have Heron's formula. So if you happen to know the lengths of the sides of your triangle, so all three sides, you can use Heron's formula to find the area. So area, capital A, of a triangle with sides measuring A, B, and C is going to be, our area is equal to the square root of S times S minus A times S minus B times S minus C. Okay, well, you might ask, what is S? Well, it's going to be 1/2 of A plus B plus C, and we call S our semi-perimeter. So Heron's formula is especially useful if you know the lengths of all of your sides of a triangle. Okay, we do not need to know the measure of any of the angles to determine the area with Heron's formula. Okay, then we have our trigonometry that we're going to use to find the area of a triangle as well. So the area formula you might know is going to be 1/2 base times height, or B times H, where B is going to be a base. Any side of a triangle can be a base, and H is your height. You can also find the area of a triangle if you know the length of two sides and the measure of the angle between using trigonometry. Okay, and so the formula we would use here would be 1/2 our two side lengths times sine, it will always be sine, of your included angle, the angle where those two sides meet. Real quick, let's just talk about where that comes from so you understand, in case you don't memorize it, how you could come up with it yourself. All right, so looking here, let's say that we want to use this A here as my base. Okay, I'm going to call that my base here. And we would need to know the height corresponding to it, okay, which should be perpendicular. Okay, so using our 1/2 base times height, okay, I can replace my B with that A. So we would have 1/2 of A times my H, my height. Well, I need to figure out what is the height, okay, of this line here corresponding to my base A. Well, in order to do that, we are going to use trigonometry. We can use this angle here. So we're going to call that angle C. So I'm going to do this down below and I'll erase when we move into the next problem. But here we would have that my height, to find that, we would use that angle C. We would have our opposite, our hypotenuse, and our adjacent. Okay, the one thing I want you to keep in mind is that adjacent A that I have just labeled, that full length of A, we are not using when we are dealing with the right triangle here that is being created with that altitude, that height that we're trying to find. So we want to stay away from that side, but we can use the hypotenuse because the full length of that is in that triangle. And I can use the opposite. Obviously, I want to use opposite because I'm trying to find the height. So that's where we're going to end up with our sine of angle C is going to be equal to my opposite, so that's that H, over my hypotenuse, which is that B. Okay, then using my algebra skills, I'm going to solve for H by multiplying that denominator, that B, to the other side to get that my H is equal to B times sine of angle C. So I'm going to come over here, and once again, I'm going to replace this. And I'm going to have that 1/2 of A times now B sine of C, because that's what my height is. Okay, and so here you can see that that is exactly what that formula was telling us. It said 1/2, which we have, the two side lengths. So here we would have A as one side and then B as the other, times sine of the angle where they meet, okay, which we had with that sine of angle C here. Okay, so that's how you could derive this formula if you don't want to memorize it. But if you memorize it, it's just a quick plugging in. All right, now I'm going to erase this just so that I can move into this next problem and have all the space I might need for it. Okay, so let's look at number 1. So in number 1, it says use Heron's formula to find the area of a triangle with the sides 4, 6, and 8. Okay, so we're going to start off by finding our semi-perimeter, our S. So I have 1/2. I'll have 4 plus 6 plus 8. Okay, so I've got 1/2. 4 plus 6 is going to give me 10, plus 8 gives me 18. And so this is going to be equal to 9. Then plugging in for my area, now that I know my S, my area is going to be equal to, we said, the square root of that S, so 9. And then we are going to take that S and subtract my sides from it. So 9 minus 4, 9 minus 6, and then 9 minus 8. Okay, we're going to reduce this. So I'm going to get that 9. Then we'll have 5, 3, and then 1. Now, you can sit here and you can multiply all these numbers together, then turn around and factor them back down into their factors so that you can figure out how to simplify that radical. Or just stop there, look and see what you can break down from here. Okay, so looking at it, that 9 can be factored into 3 times 3. The 5, the 3, and the 1 are all going to be left how they are. Okay, and then I'm going to pull out my pairs. So, and to clarify, I left them just because I couldn't break them down any. So here I have a pair of 3s I can pull out. And since I have no more pairs, I'm just going to multiply everything back together. We'll have that 5, 3, and 1. When we multiply them, we will get 15. And so that's going to give me the 3 root 15 units squared as my answer here for the area of this triangle. Now, just to clarify here, it wasn't that bad. We had relatively small numbers. You might be able to sit there and multiply them all together, factor them back down to find the simple radical form. But when we get to the larger numbers, it might become a little bit too much and you might be wasting your time by multiplying them. So it's easier to just leave them how they are here and then just factor them that way. And you'll see that in maybe one of the other ones that we'll work through. All right, so in number 2 here, we are asked to find x. And so if I look over here, my x that I'm asked to find is just going to be this height that is corresponding with the 10 as its base. So I could say, my area is equal to 1/2 of 10 times x, my base times my height. But then I have 2 unknowns. I have the area I don't know, and I have the height. So what I'm going to do is I'm going to notice here that all of my sides are given, And so I can actually start by finding the area using that Heron's formula that we just learned about. And then once I know that, I can solve for my x, my height. So let's do that. We've got 9, 17, and 10 that we are going to use here to find my semi-perimeter. Okay, so that 9 plus 17 is going to give me 26, plus 10 will give me 36. When we take half of that, we're going to get 18. So I'm going to use that in my area that we'll find. We've got 18 times 18 minus 9 times 18 minus 17, and then times 18 minus 10. Okay, so now that I have that, I'm going to go ahead and use my PEMDAS to start with my parentheses by simplifying. I'm going to get 18 times, and then we'll get that 9, 1, and then we'll have 8 over here. Okay, once again, I'm not going to sit here and multiply them. I'm going to go ahead and leave them as they are, and I'm going to try and factor them from here. So this is going to help me with that 18 because I'll have 2 times 9, which that will give me a pair that I can pull out. Then with my 8, I would have 4 and 2, and then 2 and 2. So I've got another pair, and then I'll have one more over here. So I can pull out, we'll have that 9 times 2 times another 2 to get that my area here is going to be 36. Okay, so I have an area of 36 units squared. And so I know that that area, 36, is going to be equal to 1/2 my base, which is that 10, times my height of x. So I can simplify here to get 36 is equal to 5x. And when we divide, we can get that x is going to be equal to 36 over 5 units. Or if you would like to change into a decimal, you would just get 7.2 units. Okay, key thing is, remember, only include one answer. Don't include two. I'm just giving you options of how you could write your answer. So in case you were writing it as a decimal, I'm showing you what the correct decimal answer would be. But on a test or quiz, please only pick one and just leave it as that. Okay, let's move into our next problem, where we have find the area of a triangle with the sides 9, 11, and 13. So we have another Heron's formula. So I'm going to start off by finding my S. We'll have 1/2 9 plus that 11 plus 13, I believe. Let me double check. Yes, okay. So here, when I have that 1/2, we've got 9 plus 11 gives me 20, plus 13 will give me 33. And I'm going to go ahead and leave this as a fraction, 33 over 2. And you'll see why when we work this out, why it's going to be better to leave it as a fraction rather than a decimal. So now that we have our S, let's go ahead and plug in for our area. We'll have that our area is equal to that square root, move over some, of that S times S minus RA, S minus B, and then S minus c. All right. So what I'm going to do just to make this easier so that I can see what I'm actually subtracting, because it's not 33 minus 9, I'm going to take that second number and I'm going to change it into a fraction real quick by multiplying it by a 2 over 2 so that I can get that same denominator. So we'll have 33 over 2 times 33 over 2 minus, and we'll have 18 over 2. Okay, and if you double check yourself by simplifying, you should get that 9 again. Then we'll have 33 over 2 minus 22 over 2. And then lastly, 33 over 2 minus 26 over 2. All right, so remember, when it comes to subtracting with fractions, we need them to have that same denominator. But when we actually subtract, we are only going to focus on subtracting the numerators, the top numbers, and we'll be left with that same denominator in the end. So here I'm going to rewrite this. We'll have our square root of 33 over 2. And then that 33 minus 18 is going to leave me with 15 over 2. And then we'll have that 33 minus 22 is going to leave me with 11 over 2. And then 33 minus 26 is going to leave me with 7 over 2. All right, so here, what I'm going to do is, once again, I'm never going to multiply them out. It's going to take too much time. I'm going to go ahead and just focus on looking at my numerators. So we'll have the 33 times 15 times 11 times 7. This radical that I'm going to simplify. And then we'll have our denominator, which is the 2 times 2 times 2 times another 2 here that we'll simplify. All right, so you might want to do a little bit of scratch work, which is fine. I'm going to start off with my denominator first because that one doesn't need much. Here I have a pair of 2's I can pull out, and another pair of 2's I'm going to pull out. Okay, so I'm going to rewrite this as that 2 times 2. But now we need to do the numerator. So this is where I'm going to do a little bit of scratch work off to the side here. We'll have that square root of, we had that 33 times 15 times 11 times 7. All right, so my factors for 33 are going to be 3 times 11. And that's going to give me here a pair. I'm warning now, it's going to get a little chaotic. Then I have my 15, so I'm going to draw this out down here. Could be 3 times 5, which will give me another pair. And then I'm going to be left over with that 5 and 7, and they are prime, so they're going to stay underneath the radical, can't break them down. And so we're going to pull out, we'll have 11 times that 3 times the square root of 5 times my 7. Okay, keep in mind, if you are not enrolled in the geometry AAC class is where I teach, you do get to use calculators, and so this might vary a little bit, but my students don't get to. So this is why I'm teaching this method. I apologize for the crazy dog barking in the background. All right, so let's continue on. So to get to my final answer from here, I would just need to multiply everything together to simplify. So here I've got that 11 times 3, which will give me 33. Then I've got my 5 times 7, which will give me 35. And then I've got over 4 because of that 2 times 2. And then since we don't have units, we're just going to use our units squared. And that is it for number 3. All right, now let's move into our last two problems, number 4 and number 5. So here we are asked to find the area of this triangle, and we will notice here that we are provided with a side length of 25 and a side length of 12. And so I've highlighted these just because if you notice here where they meet, okay, this angle here is given to us. It's that 35 degrees. And so this is using that area of our trigonometry formula that we gave you, which was just going to say you're going to take 1/2 of your two side lengths. So we'll have 12 and 25 times sine of the angle where they meet, which is your included angle here of 35 degrees. Now, please do not leave your answer like this. You do need to simplify. And so here I'm going to take that 1/2 of 12, which will give me 6. 6 times that 25 here is going to leave me with 150. And then we'll have that sine of 35 degrees. Since once again, my kids do not get to use a calculator, they have to leave that sine of 35 degrees in their answer, whereas for the other people, you might just be plugging all of that into your calculator and rounding where you need to. And since this is an area problem, we're going to go ahead and write our units squared on the end. All right, now for our final problem, number 5, which is going to be, in a sense, the same exact thing. Okay, here we're asked to find the area of this triangle. We are given two side lengths. We know this side length of 16 here, and we have this 12 here. Noticing that where they meet, this angle is provided to us. It is that 40 degrees. And so we can take that 1/2 of our two sides. So we would have 12 times 16 times that sine of 40 degrees. Okay, so taking 1/2 of 12, I get 6, and then I'm going to multiply that 6 times 16 to get 96. And then we'll have that sine of 40 degrees with our units squared, since they do not provide us with any units here. Okay, the one thing I do want to mention that I did see in my classes when we were going through this is just make sure you're only taking half of one number. It doesn't matter which one. You could have done 1/2 of the 16 to get 8. Multiplying that 8 times 12, you still get 96. Please do not take half of both of them though. Okay, that's going to be a big issue. So just half of one of them, since they are all being multiplied together. All right, so that's the end of this video. Hopefully it was helpful for those of you that might have been struggling with the concept of Heron's formula, as well as using the trigonometry to solve for area of a triangle.